Hi guys, today we'll begin discussing indices laws and exponent related concepts. We will be working our way through two problems. To be able to do similar problems like these on your own, you're going to have to know some basic indices laws. Of course, I am going to be talking about some of them as we make our way through today. The first problem says, given that 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x equals 4 to the power of 16, what is the value of x? That was quite a tongue twister, which tells us that we should think about simplifying the left side of this equation. We can see that there are 4 components on the left side, and that they are all equal, with each component having a value of 4 to the power of x. Therefore, adding them together would give us 4 times 4 to the power of x. According to indices laws, we know that a number is always equal to that same number to the power of 1. So 4 is equal to 4 to the power of 1. 4 to the power of 1 multiplied by 4 to the power of x, we know should give us 4 to the power of x plus 1. Because we know that one of the indices laws states that any number to the power of something multiplied by that same number to the power of something else should usually result in that same number to the power of the sum of the two exponents, as shown on the screen here. So now we figure that 4 to the power of x plus 1 should equal 4 to the power of 16. Well, if they are equal, then the exponents on the two sides of the equation have to be equal too. So x plus 1 equals 16, therefore x is 15. Hopefully that was pretty straightforward for most of you guys. Moving on. Now this one would be a little bit harder. Well, it definitely seems much more complex, but in reality it won't be too hard. You can see the problem on the screen here. We see that the denominator of a fraction on the left is 3 to the power of 5x times 3 to the power of 6. It's the same rule as the one we used for the previous problem, so that would give us 3 to the power of 5x plus 6. Now we surely want to get rid of the fraction on the left. Good news is, we see that the terms of the numerator and the denominator have the same base of 3. We also know that a fraction is equivalent to its numerator divided by its denominator. So the fraction here would equal 3 to the power of x squared divided by 3 to the power of 5x plus 6. Using a formula very similar to the one used, we also know that any number to the power of something divided by that same number to the power of something else should usually result in that same number to the power of the first exponent minus the second exponent, as shown on the screen. Therefore, in our situation, it should equal 3 to the power of x squared minus, in brackets, 5x plus 6. So 3 to the power of x squared minus 5x minus 6. As the problem states, that is equal to 1. Well, what do we know about the result of any number to the power of 0? You get 1. Well, the only case that doesn't follow this rule is when the number is 0, because 0 to the power of 0 is undefined. But we know that the base of our number is 3, which isn't 0. So 3 to the power of 0 should equal the right side of the equation, which is 1. From that, we realize that in order for our equation to stand true, 3 to the power of 0 must equal 3 to the power of x squared minus 5x minus 6. In other words, 0 must be equal to x squared minus 5x minus 6. Using some basic knowledge on how to solve quadratic equations with the factorization method, we know that x squared minus 5x minus 6 is equal to x minus 6 times x plus 1. So therefore, x minus 6 times x plus 1 is equal to 0. So either x minus 6 is equal to 0 or x plus 1 is 0. That leaves us with our final answer to this question to be 6 or negative 1. So x equals 6 or negative 1. There we go. We have completed our first of 2 lessons on indices, laws, and exponents. Hope this has helped you in some way or another, and hope you've enjoyed this video. Please like and subscribe, and see you all next time.